Hello everybody, welcome back today. Today we're going to be doing search and rotated sorted array, and that's LeetCode number 33. So let's get into it. All right, so let's get into the iPad explanation here. So this question essentially gives us a vector or array, depending on your language, and a target element. And it wants us to figure out, is this target in this vector? So first things first, what the answer is basically the index, right? So if I were to write out the indices here, for the first input, we'd see that 0 is actually located in the fourth index. So that's our answer, right? That's our fourth index answer. And then if it's not in it, then we just want to return -1, which basically signifies that it's not in this, range. And that is usually the norm for most searching type of questions. So what's the brute force approach that we can come up with? Well, I think the brute force approach is just a linear search, right? We can just do a linear search, essentially go through every element in the vector and check, is that element equal to the target? And if it is, we just return that index. And if we go through the entire vector and then we don't see that element, then we know it's not in there, so we just return a -1. The only problem with this solution is that it's actually a time complexity of O of n, right? And O of n would be okay, but in this question, actually, they even tell us that they want a log n solution. And the thing that I want everyone to think of when they say log n, especially in a question that requires sorting, is binary search. And anytime they say log n, in fact, you kind of want to think of a binary search thing, because binary search is the most common algorithm that has a log n, time complexity. So next things next is like, what do we need for a binary search? Well, we need some sort of, sorted nature, right? We need to have something sorted. And we also need to make sure that at every step we're splitting in half, or roughly half, right? And this is because if we don't roughly split by half, we're not going to get that log n time complexity that we're looking for, because the whole point is we're splitting in half, so we're looking at less stuff and then we don't have to go through all the elements, right? So let's think about how we do that, right? Let's try to come up with some idea here. So first things first, I'm just erasing all of this. I'm going to write down the vector that we got here. So 4, 6, 5, 6, 7, 0, 1, 2. And if I were to set it up just like how I would a normal binary search, I would have a low, a mid, and a high pointer, right? And this would point to this would point to the 0th index. High would point to, in our case, I believe this is 6. So it would point to the 6th index, and then our mid would be low plus high divided by 2, which would be 3, right? So if I were to draw this out, this is our mid, this is our high, and this is our low. Now, here we don't really have a sorted, like, ascending order array, right? So we can't just do a normal binary search, because then we might not actually find the element, because it's not technically sorted. It's like a pseudo sorted, right? Because the whole point is, what a rotated sorted array is basically this array was once sorted. So it was once something like 0, 1, 2, 3, 4, or there's no 3 here. So there's 0, 1, 2, 4, 5, 6, and 7. It was like this, and it got rotated. So in this case, the first example, it got rotated 3 times. So what that means is, like, they rotated left 3 times. And if you were to do that, you would get something like this. And by rotate, they just mean that they take the leftmost element, move it over here, right? It's like rotating over. So we see that it was rotated 3 times. That's why we got something like this, which is what they're showing in our input. So it's not really sorted, it's like a pseudo sorted, but it was, so what that kind of entails is that if it was pseudo sorted, that means we know it was once sorted. So one of the sides must still be sorted, because we're just moving, we're basically rotating, right? We're not actually like swapping anything over. We're not changing the technical order. We're just moving it to the end. So we know how the order is changed. It's not like a random order change. So there must be some side when it's like this that is actually sorted. And we see that here. So 4, 5, 6 is sorted. You could do another example, right? Let's say I had something like this, and I rotated it by 2. So I would have 3, 4, 5, and then I had 1, 2. But you see that how this is still sorted and this is also sorted? Same thing here, right? There's going to always be some section that's always going to remain sorted. So maybe we want to use that to our advantage, because again, if we get into a sorted section, we can just do binary search, right? So let's try to find that sorted section. So in our case, we know our target is 0 in this example. How do we check that? So how I'm going to check that is I'm going to check array at low, and I'm going to compare it with array at mid. If array at low is like less than or equal to mid, we know the left side is sorted, right? Right, left side is sorted. If the other case, right, which is array at mid, correct? Array at mid less than or equal to array at high, right? Then we know the right side is sorted, right? And we can check that right away, right? So in this case, we'll see that left side is sorted, because you see 4 is less than 7, but 7 is not less than 2. So we know the right side is not sorted. So, and another thing is, like, here, we cannot just assume that the target's going to lie on the sorted side, right? For example, 0. If we just assumed it was going to lie on the left side, we'd be wrong because there is no 0 on the left side because the range is from 4 to 7. So we need to have checks inside of these as well. First check is going to be like, and the check is very simple. It's just going to be, is this target in this range? Because we know that range is sorted. So we can just compare the target, right? So essentially, I'm going to do it the math way here. And so basically, all we're going to check is like, hey, is the array at low? Is that one less than or equal to target? And is target less than or equal to the array at mid, right? And that is the case, right? That means we know it's in that range. We want to move the right over. So essentially, we're just going to go right, or in this case, it's a high, right? High is going to be mid minus 1. Else, what all that means is like, hey, it's not in this range. So we're going to move the left to mid plus 1. Or in this case, low is going to move to mid plus 1. And that's because if it's, even though this is sorted, but if it's not in our range, then it must be in that other sorted range, right? Because there's always going to be two like sub arrays that are going to be sorted. So same thing, and the exact same case is essentially here, right? If the array at mid, right, is less than or equal to target, and it's less than or equal to array at high, if that is the case, then we just move our left or our low mid plus 1. Else it's not in this range, and then we just move our right, or which is our high, to mid minus 1, right? And essentially, once you get into the sorted range, you're essentially just doing the normal binary search here, because if you see, we're gonna be doing something like this, right? Or yeah, something like this, or like in this case, these cases. So it's just a normal binary search once you get into the sorted range. And that actually is taken care of due to the fact that we know one side is always going to be sorted from that rotated array. So let's get into the code and let's check this out. All right, so let's get into the code here. So remember, we're doing this in logarithm of n time, so we're basically doing it like a binary search like we talked about. And just a reminder that I'm doing this in C++. You can do this in any language. The concepts transfer over. It's just that the syntax is obviously different. So yeah, let's go ahead, initialize our low that we had in our example in our iPad, and our high, which is going to be array size minus 1, because we're basically going to point to the last element, right? And then we're going to basically do a normal binary search, right? The same approach will occur. So we're less than or equal to high, because once they cross over, that means we've looked at all the elements in this vector, and we know it's not there. So after that, we return -1. So I'm going to put that after the while loop. And then now it's the while loop stuff. So first we calculate the mid, which is low plus high divided by 2. And another note here is like, sometimes you'll see people writing something like this. And that's because like, the thing is like, what can happen is, it should be low. So what can happen is, if you recall, like when you're adding up numbers, if you were to overflow like an integer like data type, then this would actually give you a weird answer, right? But in this case, like I see that numbers 10 to the 4, so we're not gonna reach that, upper threshold. But in case this like, numbers was like way higher, like 10 to the 16s or whatever, you do this because like when you subtract, you're not gonna exceed that amount, right? You're not gonna add so much that you're gonna exceed it. So that's why some people you'll see doing this. It depends on the constraints, but regardless, that's sort of the approach. But anyways, the core of the question is, first, we want to check if this is actually sorted. So we're actually going to use low, right? Like we said, and we're going to compare it with mid. And we're going to check, is this the case, right? We know that now the left side is sorted, right? Another thing I want to mention about the constraints here is like, this one actually tells us like all the numbers are unique. So there's another part of this question, which is like search and rotated array 2, and I can do that later in my channel. But that one involves duplicate values, and the only reason that becomes a little more complicated is that if you're if you're interacting with a duplicate value, you want to kind of ignore that in some sense, because like in our approach, right, we're basically checking if one side is sorted, and if we find that element, then we're going to that side. But if it's a duplicate, then we might be going to the wrong range, right? Because the numbers could just keep on going duplicates. So it's a little bit weird, but don't worry about it. I can explain that on an upcoming video. But anyways, back to this question. Remember, we check this side. That means the left side is sorted. And then else if, right? You don't have to write an else if here, but I'm going to do it anyways just to make it more clear. Else if is like, in this case, right, then we know the right side is now indeed sorted. Now what we do is we have these cases inside of them, right? So we want to make sure, is this target in this range? So I can do this. So low less than or equal to target, and target less than or equal to array at mid. That's the case, right? We know that this target is in that low to mid range. So we just move our high to mid -1, right? Else it's not in this range, so we just move our to the other range. Because look, there's two ranges that are going to be sorted always, right? So we just want to pick which range we want to go into. Similar thing here. In fact, I'm going to copy this. All we do is we just change a couple of the names. But yeah, same thing. But instead, we're looking at mid to high, right? That's the range we're looking at. So that's what really changes. And in this case, we're going to actually move the low forward, right? Because if you want to look at that right side range, we want to move our low pointer forward. And then same thing here, the opposite, right? So mid -1. And let's just run these test cases. As long as we didn't make any silly mistake, we should, let's just see what we did here. Okay, yeah, I see the mistake. So essentially that thing is like we forgot the main case, which is if that array at mid is equal to the target, right? Once we find the target, because the whole point is finding the target, right? So once we find that target, we can essentially return the mid, and these can also be else ifs. So let's just run that again, make sure we pass these test cases. Yep, and submit it. This should pass all the test cases, and this is a log of n approach, right? Because we're splitting everything in half, and we're essentially ensuring that we're only checking half of that array, not all the elements. So yeah, make sure to like this video, subscribe to the channel. Let me know down in the comment section below what videos you want to see, any other questions that you might be stuck on LeetCode. But yeah, let me know in the comment section down below, and I hope to see you on the next one.